Okay. Good morning. Good morning. That's much better. So I have strange suspicion that I was strategically placed in this slot to get you all back in the room. So, but I will let that slide for sales. Thank you for coming. I know that it's pretty hard to get here back on the second day's morning. So, my presentation will be about CCR and Rs version 6 and a little bit about version 7. So I'm the lucky guy in MikroTik who is responsible for the product lineup of CCRs. So basically all the stuff that's working or not working fast enough is going through me in one way or another. Maybe some other guys are helping me out with filtering something out, but usually I end up with all the issues, put it this way, with the CCRs. So, just to make sure that we are on the same page, let's take a look what CCRs do we offer right now. Here you can see all lineup that's available right now. So we have 9-core, we have 16-core, we have 36-core devices with 1 gig, 10 gig interfaces in different combinations. So, if you have at least one of these devices, then this presentation is designed especially for you. So, tile architecture. So, it's Rs currently supports Tile.js processors 9, 16, 36, and 72 core. So 72-core device you can actually see on our table over there. So it's not just some mystery promises or something like that. We have actually something working. You can even connect to it if you don't believe us that it's working. So these identical CPU cores, I may call them tiles. So it's the same thing. Just to make sure that you understand. So when we're talking about Tilera architecture, every call is also known as tile. So why tile architecture? Because basically this is CPU solution provides everything that's necessary for us, and we don't have to worry about RPS or RQ management ourselves. There's also hardware accelerated encryption in there, memory controller, input-output controller, it's everything on the chip. So basically it's all in the chip solution. So the Tilera made a very good job with the CPUs, so that we only have to make a software for it to make our devices. So one thing that we needed to do to work on Tilera, we needed to move to 64-bit router OS. Because Tilera CPUs works only on 64-bit. So this tile architecture is first ever router OS on 64-bit, and I know there's some of you guys who are already jumping out of chairs, and what about the x64, when the 64-bit will come? Well, it looks like it will be in version 7. Looks like. Because this turns out to be a very popular feature, and I think that we will implement it in one way or another in version 7. So, but I'm not saying that it will be available in the first alpha or something like that, so don't jump out of your chairs just now. So just this comment was made just to ensure you that we are not forgetting x86 base. So as some of the trainers mentioned, some of the presenters was worried about in yesterday's presentation. So it's still an active, but that's a different kind of presentation, and that is not our core thing that we discuss here. So this is a very important slide. So I want you all to remember these 3 points from this slide, because I will use to refer to them to the rest of the presentation. So first of all, how the multi-core packet processing works. So it's all simplified, of course. not going into much details. So, but basically, after Ethernet frame is successfully received by interface driver, it's assigned to the core. So it's like a, imagine like a tour bus, and you have a guide which helps tourists to move along all the places, and there's many such groups going around. So similar things happen to the packets. They are assigned to the core, to one CPU core. Reassigning frame from one core to another core for some reason is very time expensive and resource expensive process. So you don't want to do that in your multi, or in this case, many core device. So next thing you need to realize that each core might have some jobs scheduled already. So packet processing simultaneously many cores might take different amount of time. We are talking here microseconds and even less. So that means if the packet order was 1, 2, 3, 4, they all were distributed to the 4 different cores. After processing, when they will end up, they will not be, they might be in the same order, but they might be in any other order. And the third thing, some processes, some features requires that set of frames would be under control of the same CPU core. So these 3 rules that we will use in the next presentation. So please remember these 3 things. So first of all, I told you about the hardware was fast, very fast. So is it true? It's very easy to try it out. So we introduced such thing as FastPath that allows you to avoid all packet processing through the software and basically allows straight passage, and it will show you true potential of the hardware. So what you need for FastPath to work, you need to allow it in configuration. The interface driver must have a support, so all CCR interfaces have support for the FastPath, and you need some specific configuration conditions. So currently Rs FastPaths are for simple IP version 4 routing, bridging, traffic generator, and MPLS. And we are still scheduled to add some more handlers, like for example, simple firewall handlers. For example, all the options that uses IP header can also be fast-passed, and such things. So with simple fast-pass, we get the results like this. So as you can see, 72-core device, we can get almost 70 million small packets. And as you can see, lots of results are underscored. That means that we reach the wire speeds of all the interfaces available on device. So you can't, and CPU was not maxed out in those tests. So one thing that you can notice that they are scaling pretty good. Increasing the number of cores also increase the performance. Of course, to some degree, but these are the numbers that we got using FastPath through. The obvious questions or obvious things that usually I get after the slide is, but these are just numbers. You can't get them yourselves. It's not real, it's synthetic. Well, you can. That's why we made a traffic generator tool. So you just need 2 devices, one device which will be under the test, the other that will run traffic generator tool, and you can do many things with this. You can determine traffic rates, packet loss, you can detect out of order packets, you can collect latency and jitter data, you can inject and replay snippet file. So this is very important, guys. How would my configuration work with client traffic? Easy. Sniff client traffic, put it in traffic generator, run it again. For example, if some of your clients require to drop some specific traffic so that, I don't know, kid doesn't get access to something, and you want to try your layer 7 filter or something like that, just sniff the wrong traffic, then put it on replay and start configuring your router Rs to find out that it actually works. And when you actually deploy that, you are 100% sure that it works. So what we are working on still, we are still working on quick mode, so it would be as easy as bandwidth test tool, so that you can press and test. And after we will be done, we will integrate this menu fully in a Winbox. So currently, best way to use traffic generator is from command line interface. And using, even the wiki have some pages how to test CCR devices, so you can get yourself these numbers without any problems. So then, of course, there's the next question. But what about if I use router features in a CCR? Yeah, of course, there will be some slowdowns. So, and we are not hiding that, because you cannot, on every product you can see the table like this in our routerboard.com page. And you can see that, for example, enabling 25 bridge firewall rules slows small packets a little bit, but you can see that it's still sufficient performance in medium and large packets. Same thing applies for routing and simple queues and IP firewall filters. So the obvious question is why it's slowing down so much? Well, it's not actually much if you consider that it's the whole router we need to work on, and the whole router looks like this. And this. And still this. So there's routers, as you can know, can do many things, and that's why we have the diagram to help you to see what's actually going on, when it's actually going on in comparison to other processes, and so on. So this diagram is also available on the wiki to allow you to help to understand what's going on, when, and in what order. So you're thinking, oh no, that's too complicated for me, so let's try it with some example. So in this example, we have a bridge interface. It may be a local bridge where you have bridge Ethernets and wireless. So normal home access point, and this packet coming in from the wired interface and leaving the packet, leaving the router from PPPoE. So it's the standard home solution. You've got an internet access over PPPoE, and you have a local bridge with your wireless and Ethernet. So how packets are moving are here by numbers. So it starts with one with physical interface. It moves to the decision, which requires to answer the question, is an interface in the bridge? So yes, it's in the bridge. That's why, but it's leaving the bridge in this case. So that's why it's going through bridge input. Each of these middle three boxes, bridging, MPLS, and routing, you can find a separate diagram that explains all the boxes inside. In the second part of the diagram, I will not go so deep in there. So after we leave the bridge, we then try to understand if it's MPLS traffic or this traffic should be routed. So in this case, it should be routed. So it's going to the routing forward and is trying to leave the router. But on step number 7, we find out that it's not leaving directly via interface. It needs to be encapsulated in a PPPoE. So that's why it goes, makes a hook and goes back to local out, and only then leaves the interface as a PPPoE packet already at stage 17. So just 17 steps for this simple configuration. Of course, you need to realize that packet that's going back is going completely different way. So this is the same example, only this is a returning packet for the packet that we just saw. So we receive the packet from PPPoE. So this is PPPoE packet, no bridge, no MPLS, no routing. because it's PPPoE packet, it's addressed to router itself, but before we send it to router, we recognize that it's PPPoE, so it's decapsulated. So, and it now shows up on our PPPoE interface as a Ethernet packet. And it's placed again here, so it goes again here, and now we need to do that routing part. So we do the routing part, and we of course don't forget that you still have a bridge interface over here, so it's leaving via bridge, so that's why it's going through the bridge output here, and only then leaving. So is it easy enough to understand how this diagram works? Maybe let's move to some little bit more complex example. So we have a Ethernet over IP that's bridged with VPLS that's on the VLAN. Also real situation if you use MPLS and you use Ethernet over IP to join your MPLS networks together. So these are actual examples that on everyday use. So I will not go into all 27 numbers. You can go through to check me, but I'm pretty sure it's correct. But just to illustrate to you that any configuration, any packet life through all these steps can be tracked by this diagram. And just to illustrate you how many things you should consider when you enable some router-less features. So that's why FastPass is much more faster than configuration which going through the CPU. So let's go to some of these boxes, and let's start with queues. So basically, packet spends the greatest part of the processing time waiting in the queues. But so that in order not to waste CPU cycles for waiting for until the packet will be queued and processed by the queue, current implementation just CPU core just leave the packet in the queue and go do other things. So this packet will be taken out of this queue by any other random core that working on that queue at the time. You can have only one CPU core working on the queue at the time. So there can't be 2, 3, 4 cores working on the one queue at the same time. That means that if you have a CCR device and you created only one queue, in that part you are limited only to one CPU core. That's how it works. You can't do anything, you can't work around it. So you are better out with creating many queues, then they can be distributed between the tiles. So basically, in short, what I want to say in this slide, as soon as you have some queues in your configuration, queues shuffle packet assignment to CPU cores. And if we remember that important slide from the beginning, what point was there? That reassignation of the CPU core packet to another CPU core is very expensive and should be avoided. So basically, queues are bad for multi and many core processing. So that's why we had to change something from version 5 to version 6. So in version 5 we had global in, global out, and global total. Who of you remember of those? So, but the problem with those was that global in happened in the middle or in the first part of the packet's lifetime. So that means that those packets were shuffled to the CPU cores twice, at the very beginning and then also at the end. So basically we got very, very low performance figures as soon as we got into queues when we started testing on CCRs. So we needed to change how the queues work on router-less. So before in version 5, there was global ins and global outs, and both were in the middle. Even for global out, there was still source NAT and hotspot NAT after queues. And in version 6, we redesigned that. So we put it in the end of the packet lifetime when it goes to chain input, and at very end of the post-routing of the packet leaving the router. So nothing else happens after the queues. So this way, even if the queues are reshuffling all the packet assignments, we don't really feel a big impact. So, of course, while doing this, we used the time and we finally got our hands on simple queues. So we rewrote those completely for version 6. So it now has much better matching algorithm. So before it was like a firewall filters going one by one. So checking first, second, third, and so on. So if you get over the 1,000, the last ones were really slow. Right now it doesn't matter. Right now we make a hash of the whole queue table and you just match all instantly by that hash. The principle still remains. First queue will capture traffic first, but the algorithm, how it's assigned, it's much more updated. So basically it's scale much more better. You can have up thousands of simple queues without any problems. But there is things that you need to remember as a CCR users. If you want to use all available CPU power, don't restrict yourself to one or few simple queues. You need at least 32 to fully utilize the performance of CCR devices. So 32 or more. So if you have one queue of /24, just divide it into the 1 per IP and you will see the 9-10 time increase of your queue performance. Because the device, your configuration will allow us to utilize more CPU cores in this configuration. So, what about Q3? Whole HTTP, so Q3 is based on HTTP. Whole HTTP3 from kernel perspective, so Linux kernel perspective, is and will be considered as a one queue. It's complicated tree-like queue, but it's still one queue. And one queue is limited to the one CPU core. You can't change that. Only one CPU core can work with that one queue at a time. So we will soon have the same level of optimization as for simple queues, but also you will have the same limitation now, but same requirements. So if you need to use Q3s, you will also have to make at least 32 top-level Q3s to utilize all the CCR's performance. So at this point, in version 6.19, we suggest you to use all the available HTTPs, not only global, but also interface HTTPs, and use simple queues. Because currently we are trying to make the simple queues as fast as possible, and when we will be done with those, we will move all the changes for the Q3s. So I really love MOM events for one reason. All the good stuff that's still testing in the lab or are in the pipelines are always implemented in version just before the MOM. So I don't know what the reason for that is, but in version 6.19 we introduced a software patch to improve the queue performance. So before this patch, I already told that CPU just left the packet in the queue and random other core took the packet out later on. Some of our customers complained that if you go over 1,000 queue and something like that, and you have like unreachable limits, so queue is not actually cutting nothing. So client is still like doing 50 megs, but it's allowed to do 300 megs, but you still see the slowdown. So now, starting from 6.19, we introduced a patch that requires that CPU core that leave packet for the queue also takes some packets out. Sounds very simple, but if you think about it, if queue is not full, so it's not limiting anything, not scheduling anything, then the CPU core will leave packet and take the same packet out at the instant moment. So this way, if you are not reaching your limits, your queues will work seamless. So this is changed for 619. So right now, and this is only for simple queues because we haven't gone into Q3s yet. So your simple queues should work much faster because of this patch. So next feature, tunnels. These changes were introduced for version 6.8. So basically we rewrote all the Linux kernel drivers for PPP, PPPoE, PPTP, and L2TP. So to eliminate all the CPU locks and so on, so all the packets except discovery packets now can be handled by multiple cores. And the main improvement, MPPE driver, so encryption driver, now can handle up to 256 out-of-order packets. So, remembering the first slide that I told you that important, what happens if the packets are processed by many different cores? You can lose the order of the sequence of the packets. And for encryption driver, at least the one that we had before version 6, it was very important that the packets are coming in the right order. So as soon as one packet was out of order, encryption algorithm required to resend it. So now, our driver can handle up to 256 out of order packets. So that basically means that it drastically increased the amount of traffic that can be processed by the one tunnel. So here you have a single PPTP tunnel, before the patch and after patch. Check out the small size packets. So before it was limited to 135,000, now we are over 2 million. Of course, when you go deeper into configuration, these numbers become smaller, but as you can see that there's still difference in 5 times if you have connection tracking and encryption enabled. Okay, this looks good. What about L2TP? Well, it looks even better. So, also with everything enabled, it's roughly 5 times, maybe 6. But if you disable some of the features, you can see up to 30 times faster single tunnel performance. And if you think that this is good, check out this. So PPPoE. So up to 5.5 millions on CCR 1036. So this was done from version 6.7 to version 6.8. Maybe some of you already remember that we got a lot of mail that 6.7 was the last version when this and this thing worked for me. Yeah, this is what you get when you apply big changes in Linux kernel. Even if we test intensively in the MikroTik, we still can't test all the possible configurations. So as soon as we introduce big patch, yes, we improve the performance of the problematic features, but we might break something. And we need you to write back to us and to help us to fix all the things that we broke. So basically, we then used next 3-4 versions to just fix everything that was accidentally broken by this patch. But this patch was necessary because big tunnels were very slow. So, next thing, CCR and packet fragments. So currently, connection tracking requires packet to be reassembled before further processing. So if you have some packet fragments and you just have enabled connection tracking, that's it. The packet needs to be reassembled. But it's impossible to ensure that all the fragments of the packet is received by same CPU core. So basically that means that you will have to reassign CPU cores, and if we jump back at the first slide, re-segmentation is bad for your CCR. So basically, rule of thumb is, if it's possible, avoid packet fragmentation on CCR devices. So, but we, of course, we want to help you with that. So what we did, first of all, we will, it's still in the process, in pipelines, but in one of the next versions, we will make automatic MTU calculations for all tunnels. You will not have to think, what should I write, what size of MTU should I write here if I put this tunnel over this tunnel. It will now be calculated automatically. We will add full support of path MTU discovery to all tunnels and interfaces. And we will update connection tracking to handle fragments. So it will reassemble packets only when it's necessary. So these three things are now in testing pipelines. As soon as it will look like they are working fine, we will be ready to give you to test, to check out the improvements and such things. IP firewall and CCR. So basically, IP firewall is the most memory extensive user on the CCR. So basically, if you simplify things, each IP firewall rule takes a dedicated place in the RAM, and each CPU core is going through all these RAM segments with every packet. So also in version 6.19, remember what I'm saying about pre-MUM releases, we introduced another Linux kernel patch, which finally allows us to utilize some unique Telera CPU features that optimized cache and memory management. So this solved the issues that some of you guys might see, that over some month or so, CCR performance suddenly drops and you need to reboot the device to get the performance back. So this patch fixes that issue. So we had to work with Telera and with Linux kernel developers to actually implement this thing. So if somebody is wondering what is this, I can tell you one word. It's called home cache. And you can read it all you want in the Linux development pages if you want. So, but we also changed something in firewall. So first of all, those who use version 6, you already noticed that we add all Ethernet or all wireless or WLAN, all PPP matchers in the interface. So that means that you can reduce the number of rules that's required for changing your MSS just to 2. Doesn't matter how many tunnels you have, you just need 2 rules. But also in 6.19, I really love 6.19 right now. So we optimized the option matching order within a rule. So simple options will be matched before you get to the more complex ones. So for example, if you have a rule that's matching IP address, destination port, and layer 7 filter, and your port mismatches, layer 7 filter will never start to match. So basically it will make less CPU demand on the, firewall will be less CPU demanding this way. And the second thing, maybe you already noticed, rules that can't possibly match any packets will now show up as invalid, with the comment why they are invalid. Example, you are trying to use bridge port as an in-interface. Bridge port never will be in interface, so no packets will match that option. So that's why rule is invalid, and it will be excluded from all packet matching. So there's many changes like that. So don't worry if after upgrade some of your rules become red with the invalid. Just read the comment, you will understand why. So, and maybe some of you are wondering, what is this order? So here you have the list. So it's very simple. We start with the interfaces, then we go to the headers, and only later on we go to the specific options. So usage of these options lower down, much more CPU intensive. So as you can see, I put my favorite option on the last place intentionally, because layer 7 filter is one of the most overused evils for CCR devices. So layer 7 is the most expensive firewall option. So it takes a lot of memory, processing power, to match every connection to regex that you use. So layer 7 was intended to be used only as a trigger. For example, to add some connection to the connection mark or to the address list. So direct actions like drops, accepts, or rejects, or something like that should be done by other rule than layer 7. So other rule that, for example, works with those connection marks or address lists. So you need to ensure that your level 7 rule captures each connection only once, not repeatedly. So this is the highest nightmare I can imagine, that some guy just take all layer 7 filters available, like 50 or 60 from some page, just put them in the list, and then make 60 rules with action drop.
I can say from experience that if you try to put in more than 3 layer 7 rules, match every single packet, you can wipe out a CCR with 1 or 2 Netflix streams.
Exactly. So this is trigger rule. This is not match every packet rule. Yeah, this is dangerous tool that we provided you, but you have it, so. So, routing in version 6, the next big topic about CCRs. So, packet routing itself can utilize all CPU cores, so that we get all the misunderstandings out of the way. So all CPU cores will be utilized when you use routing, but dynamic routing protocols, or more precisely routing table updates and protocol calculations, are limited currently to 1 CPU core. So 1 BGP feed will take around 3 minutes to load on CCR, any of CCRs, because it takes only 1 core, and each core is 9 core, 16 core, 36, and 70. 2 core devices have the same tiles. So on the same, all devices, all the CCRs, it will take around 3 minutes. But if you try to load 2 BGP feeds, you will have to wait for 8 minutes. And currently, if you have a board with 256 megs of RAM, you can hold only 2 BGP feeds. And of course, if you try to search, maybe somebody was already in the previous, yesterday's presentations, it might take some time to find out the rows. So, what we are still working on in version 7, but some of the things we already have in alpha, and we are testing ourselves. So first of all, in version 7, we will have around 10 times faster routing table calculations. So one first BGP feed will still take 1.5 minutes, so 2 times faster, but every next one, so if you learn 2, 3, 5, and so on, will take much less time. So they will scale much better. So basically, we played with something like 60 full feeds already. And we reduced the time it takes to load, and we reduced the memory that it takes. So full BGP feed will now take only 36 megs of RAM, and 12 million rows, that's the highest number we actually tested, will take only around 500 megs of RAM. So also the new kernel will allow us to make completely isolated VRFs, and will allow much faster routing table searches. Just to avoid any confusion, both version 6 and version 7 routing calculation will be limited to single core. Because you can't simply multi-core that thing. But with these optimizations, we don't think it will be an issue. So stop asking us when we will multi-core routing, because it can't be done. It can be optimized, we know about it, we use new kernel features, and that's coming in version 7. But still, you will see 100% load on one CPU core when you load your BGP feed for smaller time than you do in version 6. So that's just to avoid some confusion. And it's not us, it's Linux kernel, that's the way it works, simply as that. But we try to make it as much faster as possible. BGP is almost done. We still are working on OSPF and other routing protocols right now. So that's the current stage of Rs version 7. So BGP is finished and it's undergoing testing right now, and we are working on other protocols, actually writing them from the beginning. IP security and CCR. So good thing is that CCRs have these hardware accelerated encryptions. Also, we struggle a little bit in the first Rs version, 6. something, 1 to 7. We got in 6.8. We finally enabled them. So our test back then showed that CCR36 can handle 3.2 gigs of encrypted IPsec traffic. It showed around 80% CPU load. I used no fragmentation. So as I discussed with you, the fragmentation is bad for you if you use CCR. And again, if you use CCR, you need more than one peer to get these results. In my case, I use 100 peers, and AS128 was used. So, as you can see, that version 6.8 was one of the cornerstones in CCR development, and you probably can guess that that version was just before MOM Europe. And now we have version 6.19, that's I hope is next cornerstone, and it's just before MOM US. So please test those versions, report everything that you discover. So, but if you still have some issues, some performance issues and so on, how could you see if you are limited by Rs software, by one CPU core or something like that? You use tools. You use system resource, CPU, that shows you the list of cores and how much each core is used. So you need to look for 100% load on some of the cores, and then you can use tool profile to actually see what part of Rs is using this CPU core, and then you can find out what is the bottleneck in your case. And then, of course, somebody of you might consider that, but I'm afraid of using latest versions. There's so much changes that something might break. We are not saying that everything is fine. Yes, it's possible that something can break, and the golden rule of IT is don't touch what is working. So that's why we allow you a little bit flexibility in this issue. Partitions. It's very underappreciated feature. Yes, the name is in the CCR, but I don't really know how would I survive my testing part without it. So you can have up to 8 partitions on CCR. You can always have working version, tested version on your network on some of those partitions, and you can try the new version out on one of those partitions, and just one reboot, and you will be back on your version that you are sure of. So this is really a feature that you must use if you want to stay up to date with our CCR updates. and be safe that you can always get back to version that you aren't sure of. So ideal solution, just make partitions, upgrade to the newest version, test if everything working. If you discover some issues, make a subaltry file, debug logs, send it all to us, reboot back to your working partitions, wait until we send you a version with the fix. This is how guys are actually working on a daily basis. Some of you might have access to RC versions already. This is how those guys are reporting issues. So partitions, partitions, partitions. So let's just summarize what's up with what's next with the CCR. So first of all, of course, fix all the issues that we might have with all the improvements, all the kernel patches that we introduced in version 6.19. Implement this automatic MTU calculation. So when I was leaving for Mexico, the developer was actually writing this stuff. So I hope I will have something to test on my return. So if all the changes in simple queues for 6.19 worked fine, we plan to apply the same changes for Q3. And there are a few more patches that I'm not allowed disclosed at this point, but we have a whole lot of things in pipeline to just improve CCR product as such. So we are still working, and the product will get better and better and better. So that's it for me. Do you have any questions?
I don't know if it's so much as a forwarding or packet performance issue, but randomly our CCR 1036 looks like a 60 data unit. When we go to try and do testing or update the software package, we no longer write NPK files or anything to the file source. It just randomly stops accepting any file store changes.
So we had a file system problem in earlier versions.
I think we're on 6.15. We can't.
From 6.12, we had a file system issue on the CCRs. I think we fixed it in 6.17 or 6.18.
Also, the thing is, I can't write an APK file to it.
This is file system issue. It requires you to net install device to reformat the NAND. So just to make sure that it not happen again. So reformat the NAND with the newest 6.19. It should be fine.
Are there any plans to make a hardware platform that's narrower? We have some sites that the box can't fit a full rack mount, but it needs the higher performance.
If you need some device from us, you just need to inform us. Best way is to support at MikroTik.com. So as soon as there will be enough requests, enough demand, we might consider to making it. So far, every CCR that I have seen is limited to rack mount.
You mentioned in the new change log for 6.20 requiring version 3 of Winbox. How's that going to affect the dude?
So dude is not dead. We at MikroTik we always have to make very, very hard decisions about do you want dude or do you want better, faster queues. So if you have to choose right now, so yes, with all the changes that we made to Winbox, to RouterOS and such things, we need to remake the tube to the new version that's current and so on. So I hope it will be soon, but I can't give you any estimates.
With BGP optimizations, are you going to implement counters and filters so that you know when filters are actually being, hit?
Routing filters.
Routing filters.
I don't know by heart. I need to recheck that one. Just write to me. I will check it.
Thanks.
Yes.
Earlier on, you were talking in order to maximize performance in queues that you would need to use the minimum of 32 queues. Can you give an example of how you would balance the traffic among those queues to actually do that to increase performance?
So the simple way, like if you use Mango, you can use some pair connection, matcher to distribute connections between those. Instead of limiting the whole subnets, you limit IPs of each customer to some level, things like that. to just go deeper. Just forget this, I will make one big queue thing. That doesn't work on CCR. It's not meant for that. Okay.
Do you have any comment on the Telera acquisition by EasyTip? Is this good or bad for MikroTik?
That's out of my reach. I have no information there. I'm a technical guy that works with the hardware that I have it. So I can't comment on that, sorry. Over there.
Was you were saying that the BGPs and stuff goes on with one processor? If you have BGP and OSPF on the same cloud port, does it use multiple processors?
All the things will be fine in version 7. Don't worry.
Earlier we were talking about router filling, and I know he had mentioned that, you know, when you're trying to sort through your routes, especially after a change has happened, that it takes forever to find that change, and, you know, sitting there and waiting. So is there any plans on possibly implementing some sort of indexing or hash?
This is not version 7 presentation. There are many plans and so on. If you want to make sure that we don't forget your feature that you need in version 7, write to us.
Okay.
So that we can check out, because it's still in the early alpha, and the only things that we are concentrating right now is performance, and then we will finish up on all the features that are required. We have the whole list there. I don't know it by heart, so I'm not writing that code. So please write to us, we will check that. So right now, let's concentrate on the CCR.
Is it true that bandwidth test is single thread, single core?
Yes, and that's why we encourage not to use it on CCR.
Is that going to change ever?
No, we actually, I hope, that's my opinion, that's not official opinion, I hope to get rid of bandwidth test at all and replace it by simplified version of traffic generator.
Will you be able to use traffic generator from one device to another?
Possible.
Okay.
That partition thing, is it only on the CCR or?
No, on every router, except 86. So all the router ports, cloud router switches, and cloud core
Is
routers.
there any way you guys can have it on 86?
Possibly, but the demand hasn't been high enough. Even on guys on the router ports don't use it often. I don't know why. It's a very useful feature. It's like a backup, free backup inside the router. So, yes?
When you implement your partitions to prep for new software, how do you normally go about doing that while still, or to get that ready before you put that in? Because when we first tried to use partitions, I remember you really couldn't configure them offline.
Yeah, currently configuration offline is not implemented, but you know, in MikroTik we work on demand. Most popular features are implemented first. So nobody uses partitions, so nobody asks to upgrade those partitions, but possibility is there. Yes, you should be able to easily apply a config or change a config on partition that's currently offline, but it's not implemented yet. So
How would you go about doing that not on the router board, but how would you do that now with other resources?
So basically, you will have to apply the configuration and then just copy it over to the other partition. That's how it works right now.
Okay.
Yeah, you can copy to any partition you like from the current partition. Yes?
When you guys go to version 7, is there plans to create a list? You know, you talk about x86 support, because we've had problems with drivers on certain Intel chipsets in version 6. Are you guys planning on redoing this is the supported hardware, or this is the tested hardware?
It's solved before us. We will just take a Linux kernel version. I'm not sure which one it will be, but it will be one of the latest. And we will just magically support all the drivers that's supported by those Linux kernel versions. So if there is a driver for that Intel interface that you are worrying about, for that Linux, we'll just need to write one line and it will be included into router OS. So, yes.
Is there any plans to improve the support of RIF tools to improve visibility, you know, in complex configurations where it can be hard to find a problem, you know, hard for you to find a problem. So we run the support to RIF, and then you say, well, you you know, the information that you need is missing.
Nothing to announce at the moment.
I guess I've never used the partition before, so I feel kind of stupid not knowing I haven't used it. So ours has the file system problem. If something is really broken, like, and we have to be hands-on to do the net install, we have to use the power side to do it, that one. Is there a way to boot to a partition from, like, say, using the...
First of all, if your router crashes for some reason and so on, and can't boot up the first partition, something got corrupted or something, it will automatically jump to the next one.
So it seems like the Windows and the bootloader don't jump in there?
Exactly,
Okay.
exactly, yes.
Right now, all of our router boards say they are upgradable to version 5, 6, 7, whatever.
That's the option is removed for all the router boards. If you have a router board, you will be able to upgrade it to whatever version it survives.
That's cool.
It was removed in 618, if I'm not mistaken. No more questions?
Yeah, I got one. Going back to the partition, I've not used it either. How do you manually choose which partition you use?
Buys, serial console and buys or router board menu, as you choose the frequency, CPU frequency and stuff, there will be a partition option also. Okay, no more questions. Thank you for attention.